Hi, Scott. I'm so happy to have you here today in this call. And I want to hear your story about the helmet-based ventilation and how it all began. And introduce yourself to us. Tell us what you do and how did you got on this project?
So my name is Scott Loree. I'm a Calgary-based emergency physician, and I have a fellowship training in wilderness and disaster medicine. So I'm familiar with care in austere environments, and I have a substantial interest in rural medicine. I spent the first half of my career doing rural medicine in various different hospitals in Alberta. Often where there's one doc in town and where there is 2 or 3 nurses on at a time. And when COVID started ramping up, and we started seeing more and more people needing ICU care, I started to worry about what was going to happen in a lot of these smaller places because, while they're capable and they can intubate a patient or bag them or keep them ventilated for hours if they need to. I and many of my rural colleagues have been in a place where they've intubated a patient and EMS is busy and can't come and take them away. There's no ventilator available. And so, we've bagged patients for 2 hours, 3 hours, 6 hours, 12 hours, that kind of thing. And it's not fun. And so I started looking for a solution. Then I saw a video from Italy with all of these helmets in use. And that inspired me to go looking as to whether that would be a good solution. Why were they using these in the Italian ICUs? Maybe they know something we don't. And so then I went searching across the internet. I found the companies, Ceylon in Texas and Amron in California, and Intersurgical, of course, in Italy. And quickly concluded that they would be tapped out with their supply as far as unable to provide enough, at least for our local use. I suspected that Ceylon was going to ramp up and be able to supply the United States and maybe even somewhere else in the world. But if they're sending them to, say, Brazil or something like that, I didn't want to siphon off a bunch of their supply to use locally. And then there was border closures and other restrictions and concerns as to whether we could even get them here. So I concluded that, if we were going to have these things here for use, we would have to build them locally. So then I went looking around the internet, and that was about the time when you guys started your site. So that was quite a good validation and resource as far as being able to see what was going on in other areas. It was a good window into what UChicago had done as far as the research and the protocols and the use. And then I fired out an email to plastic manufacturers in Alberta to try and find somebody who was interested in collaborating on developing this thing. And a fellow named Don Hofer responded, who is on a Hutterite colony. And I don't know if you're familiar with Hutterite colonies. They're sort of like, not quite like Quakers or Amish, but they're fairly insular and live in a sort of communal farming type setup. These
like
guys have
Amish in the U.S.
Yes.
Okay.
Almost. Not exactly the same.
Okay.
But it's a similar kind of communal farm setup. And they have a plastics business. They do plastic bags. And so he was interested in helping me. But he doesn't have any capability to manufacture hard plastics like a neck ring or that sort of thing. But he does have a good friend named Tom Vermeeren, who's in Edmonton and runs Gemma Plastics. And they build all kinds of things from oil field parts, custom oil field parts for fitting pieces of oil field equipment together and repairing one-of-a-kind oil field equipment and that kind of thing, all the way to plastic bags and all kinds of stuff.
Mhm.
Small business, you know, he's got like 6 or 8 or 10 employees most of the time,
Mhm.
but big enough that they're capable.
Mhm.
And Tom was quite enthusiastic about it. In fact, he had already ordered, believe it or not, 20,000 liters of ethanol to make hand sanitizer and build the bottles for the local health authority. So he
Nice.
was already in it up to his waist. And so I dragged him in and put him in up to his eyeballs. And so Tom took a look at it and said, yeah, we can build that.
Mhm.
Great. These are the other people's designs, and this is the commercial design, and this is what has been done. And he said, I can do that. So he emailed me, you know, a couple of drawings. And we've been through several design iterations. The initial plan, he was going to use a foam, he thought, to cast the neck ring with a stiffener inside it.
Mhm.
And so the foam would then, you know, be on the outside and form the neck ring and then curve up and sit against the neck. It's going to be an EVA foam similar to, well, not quite a pool noodle, but, you know, soft foam.
Similar to it's something soft around the neck.
Yeah.
Mhm.
And he cast a bit of it around in a makeshift mold and came to the conclusion it wasn't going to work.
Hmm.
So then the next thing he went with was Dragon Skin FX from Smooth On. And this is a special effects product that they use to build makeup prosthetics. So, you know, wounds and people missing eyes and aliens and all kinds of different special effects things. And that's nice and soft. And he cast a ring out of it, and that worked spectacularly. But it was a little bit not quite as durable as we wanted it. It sealed great, it stretched great, but he wasn't happy with the way it sealed, and it gave him problems with the neck ring.
Mhm.
So he designed a neck ring, and the first thought was to 3D print a master, and then cast it in polyurethane multiple times for production. But the 3D print shrunk about 0.5% on us when we printed it. And so we ended up with a canceled testing day because the parts wouldn't fit together. And yeah, it was frustrating. So then he milled out a neck ring out of a solid chunk of plastic.
Mhm.
And he has a talented machinist up there by the name of Patrick, who's, I think he's Polish, and has worked on a ton of design things like artificial hands and all kinds of things.
Aesthetics. Mhm.
Designer and draftsman and mechanical engineer and other things.
Mhm.
Anyway, so the two of them decided that also when they tried to clamp the neck seal against the hard plastic ring, they were having trouble with the soft silicone not staying easily or not going in easily. Just because it was too soft and squishy, it didn't clamp nicely.
Mhm.
So now they're on to injection molding, which was, you know, a bit of a step further. But you've seen the pictures that I've sent with the metal mold that he's got for it. And he's working through a couple of different materials to get the right elasticity that he wants out of it.
And it's
Uh,
amazing when you say metal molding, you know, to make a molding, it takes months sometimes. So this is such a, like, I don't know anyone who was able to make a molding so quickly and actually start making the, you know, to start to using it. So how did he do it? Did he like worked for a week, no sleep, or, you know, what's the secret? Or did
blame
he have some help?
blame Petrick. So this fellow's a mechanical engineer and a machinist. And in their shop, because they do custom parts for oil field and everything else, they have a CNC machine, a CNC mill. So this is a computer-driven mill that can mill shapes.
Okay.
And so they took a square chunk of steel and put the mill on it, and it took about, I don't know, 30 hours or something of cutting, and the machine just cuts and cuts and cuts and cuts and made themselves a ring.
So good connections there. You know, you had a good team.
Yes, yeah, no, the success is largely due to their efforts on that part.
Mm-hmm.
They've been stellar. There's a lot of clamor online for us to release design files and show people, you know, what the design files are and what's happening. The problem is that every time I talk to Tom about releasing the design files, he's changed things. And he really is reluctant to release anything that he knows won't work. And so we're on this treadmill of, you know,
Mm-hmm.
can we release files? Can we show people what's going on? Well, no. I've changed this and I've changed that. And so it's an optimization thing. And the other part about this that I've learned is the manufacturing issue.
Mm-hmm.
Manufacturing is quite hard. And I built one on a 3D printer and, you know, with a plastic bag and had it work. You know, you've seen Yuri Gelland online with his, you know, plastic bag and an ET tube and PEEP valve and taped around his neck. And several other people online, Merrick and other people have developed things. So you can make a few of them, half a dozen, but we're talking about making 50, 100, 200. 200 is our sort of goal for production. 200 is a lot to make on your kitchen table. And then there's the fact that healthcare workers are not makers. They're not interested in fiddling to make it work. If it doesn't just work and go on and do what it's supposed to, they're not going to want to use it. And that feeds then into acceptance as well, because the health authorities are not interested in something that's manufactured on the kitchen table unless they're stretched, you know, under-resourced settings, stretched settings, uh, places that are over these home-built MacGyver prototypes. But in the first world, I think fear of lawyers and lack of utility will probably kill anything that's not and easily used. The process turned to getting approval to use this. And our provincial health authority here in Canada, we have basically a state level unified health apparatus. And so we have a plan for COVID across the whole province. And, you know, all the way to which hospitals are going to do which things, and the hospitals cooperate together. They're not in competition at all. And that sort of thing. So we talked to the Zone Operations Center, which is in Calgary here, and a fellow named Jerry Lombardo does procurement for them. So he's going like a crazy man, getting masks and, you know, gowns to different places and supplies and that kind of thing. And he said, yep, we will be willing to look at it and use it, which is about the most approval you can expect from a bureaucratic organization, if you can get us some samples. It would help, though, if you had Health Canada approval. And I said, oh my. Okay, well, then I went looking at the website, and Health Canada has a special approval process for emergency COVID-related medical devices. And so I put together the information we had, as well as a bunch of the University of Chicago information from your website, and a good list of the rationale for it, a good analysis of failure modes and what might go wrong here and there. You know, what happens if the power fails? What happens if the bag bursts? What happens if the, circuit becomes disconnected?
Yeah.
What happens if the patient vomits? And ran through that and submitted it. And there was a couple of people at Health Canada, Emily Smalling and Melinda, I'm trying to remember her last name. Anyway, Emily and Melinda wrote back and asked me a bunch of different questions. I had to create a label for the device, believe it or not.
Wow.
The labeling for a medical device is very important, apparently. And
even in emergency cases.
Yes, we had to create a label that had the correct information on it.
Okay.
And we had to come up with an identifier. And an identifier is basically a catalog number, apparently. Who knew? But the principle is that medical devices, a lot of them sound the same. And so they want a code of some variety that you can use. So I just made up Alberta COVID CPAP version 2, and they were happy with that. It had an identifier. But, once a few of those little bureaucratic bumps were over, they had the pieces they needed to enter into their database, and their doctors were satisfied that it wasn't going to be overtly dangerous and was, useful.
Mm-hmm.
They issued us Health Canada approval.
Amazing.
And a letter for Health Canada approval has to go with every hood. And we're required to track adverse events. So my plan is that everyone that uses it should be emailing us back the results and, status of why they used it and what vitals looked like in a, brief case report kind of thing. And that constitutes approval. So now Tom is a licensed medical device manufacturer.
So how long it took to get approval? A week or 2?
10 days.
10 days. This is
a couple solid days of work, sort of crafting and wordsmithing and gathering information and studies. And, I did the literature search and pulled down all the literature I had. And I sent along the videos from the University of Chicago. At that point, you guys had just put up the video tutorial, kind of introducing and tutorial thing. And so that was all very supportive. And they quickly came to the conclusion that it wasn't dangerous and that our manufacturing plan was responsible and usable. And so even though we hadn't finished our prototyping, they gave us approval.
Amazing. So when do you think you will have the first helmet on a patient?
I would hope in a week or 10 days. It's a little bit hard to say. I kind of feel Elon Musk-ish with continually pushing the deadlines back. But Tom is working hard and doing his best, and it's a matter of making sure that this is right. I've mentioned online before, there is sort of a variation between it works and it works good enough and it's perfect. And we all know perfect is the enemy of good when you're making things. But not good enough or just barely works is sure to sink the project.
Yes, and you're right, because when I hear the feedback from clinicians, the biggest mistakes that I see, so first of all, there's always a learning curve, right? So I can tell you how many times the doctor would say, the first question is, did you see the guidelines? Well, I went through it quickly. So that's already a first big mistake. And this would be my personal advice to everybody who's gonna try the helmet on the patient. You really have to look at it, look at the guidelines, and use the application if you want, and your smartphone or computer. You really want to get those step-by-step, guidelines and the suggestions and troubleshooting, because you don't want to do all this, stressful taking off or, connecting on a patient. So my, biggest suggestion to everybody, first of all, look at the guidelines and not just once, and you have to really, really learn. And then the second, like you said, the product should be easy to use. There should be nothing, disconnecting or nothing ripping off or something, because that's, again, it makes people so frustrated. And like you said, clinicians are there to take care of the patient, not work with the, issues with the helmet or any other devices, especially now during the pandemic. You guys working like, hours and hours without any days off. So at this point, you end up being so tired that you just don't want to deal with any problems like that. So, so yeah, I did see you, try the helmet. You guys connected to the gas flow and everything. So you put it on yourself. How did it feel? How can you tell me a little bit about it?
So part of the process that I went through there was to reach out to see if we could get a couple of commercial units from someone to use in comparison anyway. My thought was to ultimately be able to show to the IEP and C staff, to have them sort of compare and say, yes, it's functionally equivalent to other commercial things that are out there. So I tried to get hold of Ceylon and Amron and get them to send me some, and they just were overwhelmed. There was no way.
Yeah.
But a fellow named Thomas Fox at the center, the hyperbaric center in Montreal, put me on to the idea that there are several multi-place chambers in Canada that use these for hyperbaric medicine. Now, we don't have public hyperbaric multi-place chambers in Alberta. There's a few in BC and some in Montreal, but I found, believe it or not, a naturopath who has a hyperbaric chamber and uses these in Edmonton.
Nice.
He doesn't use it much because the economy's been down and people and whatever. But she had an Amron hood that she shipped to me. So Apotec Naturals sent me a Amron hood. Now it's the hyperbaric version, doesn't have the clips to hold it from popping apart. That was the first thing that we discovered when we pressurized it. So then the binder clips came out.
FDA approved.
But yeah, I put the thing on and showed it off to the staff, and that's where the pictures of the crash cart with me connected to, oximetry and end-tidal CO2. I stopped short of letting them put an ECG on me. But yeah, we ran an end-tidal CO2 into the mask, actually, into the helmet, actually, and ran the sampling line around kind of by rolling around on the stretcher, and checked the CO2 level at various locations in the helmet.
And what did it show?
0 up to 16 if it got close to where I was exhaling.
Okay.
So I was wondering whether we need the gas flow that you guys have specified coming out of Chicago, the 40, 60, 80, 140 liters a minute. Because when I did this, I ran it anywhere from flush, which is where I started, sort of as high as our oxygen system would go, which is probably 50 or so liters a minute, all the way down to 15. I didn't go lower than 15 because I started to get a lot of collapse with tidal volume. But I wonder whether we can get away with lower gas flows.
Well, the suggestions from UFC and also what I hear from doctors in Italy, no less than 50, 60. Yeah.
Okay. I haven't had anybody in it for, 14 hours, which might be the...
And again, if you are, young athlete, strong person who can pull that air in a helmet, you will be okay. But if you are sick and you are weaker and you already working hard and breathing, that's what you want to keep in mind. That's why we need a high flow.
Right. There was a very interesting suggestion by a fellow that goes by Francis Musical online. He's a bit of an interesting fellow, has lots of creative ideas. But one of his suggestions was, well, why can't we pressurize it with air? and run an oxygen tubing inside and put a mask on the patient in order to conserve flow. Haven't tried that yet, but that's on my list of things to try next time I'm in the hospital and have some free time.
Yeah, that's an interesting idea too. So you kind of saving some oxygen.
Well, you, I suppose, be able to turn the oxygen to 15 liters or so, non-rebreather kind of level, and pressurize it with medical air or that kind of thing. You can run the medical air at 60 or whatever high amount you need to. The oxygen flow in the mask, I assume, would evacuate any CO2 that was exhaled and would limit the amount of rebreathing. Then you would be breathing mostly what came through the mask. I mean, we all know these non-rebreathers aren't true non-rebreathers, but
yeah, and just again, you have to look at the patient, because some are mouth breathers. So, if it's going oxygen into your nose, it's not going to help very much if you are a mouth breather,
Yeah.
So, again, things to try. And I have a feeling that we will hear a lot of interesting data coming from people who are inventing now. I mean, inventing, it's already invented, but we actually modifying the helmets and making different designs. And I understand Tom very well, why he wants to make a perfect design, right? A good design that doesn't fail, because the same is happening in all these companies that are making helmets right now in the US. They're constantly improving. So even in the videos, when you see my reviews about the helmets that I have, we're already making changes this week, and maybe next week I will have completely different reviews. So it's very safe not to rush right now, because with releasing your designs and because it's gonna, again, for some countries it's gonna be very expensive and they may fail, and again, when the equipment fails, doctors don't want to go back to it anymore. So I think it's smart to wait and get the best helmet design that functions the best.
Yeah. The other advantage we have here is that the public health apparatus and the population have done a spectacular job as far as flattening the curve. And so as far as, projections for COVID, R naughts, and that kind of thing, we're seeing best case scenario. Our expanded ICU capacity is running at, 30%, 50% kind of thing. And so we're not seeing the load that we anticipated we might see at the end of April. We're not in a New York kind of situation. We have a little bit of luxury of time, but also there's the emerging information out of, say, Scott Weingart and Cameron Calsadell and Gattinoni and these critical care fellows that are suggesting that intubation might not be the best idea. I'm not sure that it's the intubation specifically that's not the good idea, as much as once they're on a mechanical ventilator, you end up chasing numbers. Yeah. You don't have a conscious patient who can say, yeah, I'm breathing harder and working harder and that sort of thing. So you end up dialing up the PEEP and FiO2 to try and get a number, pick a SAT, 88, 90, 92, whatever they're going to go for. And I think that's breaking lungs.
Yeah, so and this is what is really hard for the physicians to do. You following the protocols that are for ARDS, and it's okay, it's protocol that worked all the time, but unfortunately with this virus, we're finding out that the picture doesn't look the same, and it can be walking, talking person with saturation of 60 or 70, and you will, so physicians feel like, oh, I have to intubate because that's what the protocol says, but the patient is talking on the phone, like, so this is why you really, what happened in Italy at the beginning, they started to intubate everybody because this is, you following the protocol. Yeah, you feel like we're gonna crash. I have to help. If I'm And even we tried to intubate as early as possible, but the outcomes were the same. And the one biggest thing that we found, it's the high PEEP, that based on the ERDS protocols, you have to go, sometimes on the PEEP. So now we're suggesting as much as possible, use the non-invasive with, again, a low PEEP, and same for intubated patients. So do you see that non-invasive ventilation is more and more used in Canada now? And do you guys usually use the high flow nasal cannula or face mask? What's the?
So that is the fly in the ointment. That is the one hitch with developing this helmet. Mm-hmm. The local respirologists who have written the protocol or the guidelines for using non-invasive ventilation are not very supportive of non-invasive ventilation at all. They are still advocating intubate at 6 liters nasal cannula. If they fail 6 liters nasal cannula, intubate them.
Yeah.
The emergency docs are starting to have seen enough patients that they're starting to doubt that. The information out of Ottawa and Montreal that are a bit harder hit and have had a little more volume of patients is starting to support the information that's coming out of New York and internationally. Yeah. So it's the winds are slowly changing here, but there is a bit of a headwind as far as the establishment is concerned. And so the thrust of my deployment, or the thrust of my interest for this, is going to be mostly rural, because we have, places that are 2, 3, 4, 6 hours drive from an ICU. And you can imagine what would happen with an intubated patient out there. I mean, you can bag intubated patients for as long as you need to, but the volume control isn't there. Even with a PEEP valve, the PEEP varies, and you don't have any idea what volumes they're taking in. The Untitled CO2 gives you a little bit of idea about how well they're breathing out. It's not intensive care. It's not a critical care kind of level of support. And I think the patient's own physiology is more finely calibrated to be able to take care of that than an ambulance, a medic in the back of an ambulance. If you don't have ABGs and an art line and everything else, I think we're better, at least in this case, to let the patient manage their own respiration.
Exactly.
As well as the entire concern about aerosol generating medical procedures. We have our new big hospital here in Calgary has every room in the emergency department is negative pressure.
Wow.
The sliding glass doors and whatever. Some of them are even like full negative pressure rooms with an ante room and the whole business. But most of the hospitals in Calgary don't have very many of those, a couple or 3 in each emerge room, and none of the rural facilities do. It's 3 stretchers in a bay with curtains. That's the emergency department, and they aren't equipped to aerosolize a treatment. And so the recommendation against CPAP also comes from that. The respirologists from an infection control standpoint don't want to aerosolize all over a lot of these facilities. And, that's definitely a valid point. The helmet solves that.
Yeah, exactly. Especially when you have a better seal around the neck, and that's what you're working so hard right now to get that seal. It seems like that's the hardest part actually for the helmet. And I'm hearing it not just from you, Scott, I hear from everybody else who's working on it. It's the neck seal. And another benefit of the helmet is that patient, again, can move and prone himself. So that's early proning, again, shows a good benefits, for the patients. And at the same time, it's you need less staff, because to prone an intubated patient, you need at least 5 people. And if you're going to do it every day, every 4 hours,
an hour or 2, good luck.
Yeah, it's impossible sometimes to do it. So yeah, so I'm very happy, that you guys are working so fast and inventing and, upgrading your helmet. So I will be waiting for the first videos, and when you have on a patient, and actually if the patient can tell his story, how it went, it will be amazing, because it will help a lot of other clinicians, to understand how it works, and what are the benefits. And again, we cannot say that it's going to work for everybody. We don't have research studies yet, but the Italians say that it's about 20-30% of the patients in the helmet, they avoid intubation. I don't know what that number is now with all the PEEP adjustment to make sure that the PEEP is not super high in the helmet too. Maybe this number is even better, but that's just me guessing.
I suspect that number may rise with changing goals as well. So if we're willing to accept a saturation of 80 or 82 or 85 rather than 95, they may do even better with the helmet.
Yeah.
Rather
And
than
that's how we said, you have to look at physiology, don't look at the numbers right now, look at the physiology, look at the patient and see what's happening, and then make decisions based on that. So think outside the protocols. Protocols are really good, and I hope very soon we're going to have a protocol for crowded patients. That's going to be perfect, and everybody can follow. But right now, unfortunately, we don't have one that everybody agrees on.
Absolutely. And the protocols are useful for not having to think, but we still have to continue to exercise our brains on top of that.
Yeah.
Speaking of the sort of development of this, the tutorials and protocols and information that you've put online with the website are extremely helpful. Those are basically most of my plan for instruction manual for this thing. Is to pretty much, it needs to be written as well, but to connect them with the information out of the website to be able to educate them as an in-service kind of thing, because there's no way we're going to be able to give everyone experience with this before they use it.
Yes, so this is like a software for the helmet.
Yes.
All the protocols, guidelines, and I was really happy when Amplify contacted us and we said, this is what we made. Do you want to use it? I'm like, absolutely. So, and there will be more protocols coming out from different hospitals that are using helmets in US. So one will be coming from Penn University. So I'm waiting for that to see. And now actually the tool is available in Spanish. So this is going to be great for, other countries that are working on the same project. Also, I did notice you have a Gofundme page, right? So definitely, I'm going to say, please, who's watching this video, who's reading this article, please help Scott and his team to make these helmets available in Canada. Money at this time is really not a major issue. The most important thing is to have these supplies, to have people working with it, and to save the patients. We're going to put that link on our website too.
For sure. We estimated it would be about $25,000, give or take, on a cost recovery kind of basis for materials and Tom to pay staff wages and that kind of thing to produce 200 of these. That's ended up a little bit optimistic in as far as respiratory parts and that kind of thing. I just had an estimate for $6,000 for 200 copies of the filters and PEEP valves to make it a kit, because I don't really want to send it out and expect everybody to be able to find all the parts to make it work. That's another one of those fiddly bits that if it doesn't just work, it won't work. So
so the price. And so the price for the kit is like what, 125?
That's roughly what we're projecting. About $25 of respiratory parts and about $100 for cost recovery for these things. The plastic bag is pennies a piece, but it's the casting and the injection molding, the seal, and that kind of thing.
So now, will you be able to reuse your helmets?
So that would be another hurdle. That involves doing some testing as far as disinfection and that kind of thing.
Mm-hmm.
And it's not as simple as just saying, well, it's made out of polyurethane, so you use this kind of wipe on it, and that's how you disinfect it. That's the start, but then Infection Prevention Control wants to do testing. You know, they want to seed it with Staph aureus and then wipe it down and see whether it works.
Okay.
So, you know, that's a whole other layer. So for the moment, they're single use.
Okay.
I think probably in the future they could be built to be multiple use, but right at the moment it's not practical to go that far.
Okay.
And you know, we've dodged sort of the bureaucratic approval that way, as well as we've dodged the bureaucratic approval of getting them to spend money on this by going through the Gofundme. The trouble is convincing them to spend money on something they've never seen before and never used and might or might not work and that sort of thing. And so charity was the only option there, you know.
Yes.
And that will just that will get us a toehold.
Mm-hmm.
And the timing is fortunate in that, you know, Chicago is using these and Penn is using these, and you know, the acceptance is growing, the protocols are growing, the, you know, news of how they work is growing, and I think the timing's about right for everything to come together for it to go.
Yeah, and we have to remember that the fall is actually coming to the southern hemisphere, and I hope these countries will have helmets available because they are producing now. And what I know that U.S. companies are shipping some of the helmets to these countries, even to Europe. I can tell you, like Spain, for example.
Excellent.
So it's coming from US because unfortunately Intersurgical, they just not shipping anything outside the
No.
Italy. And it's understandable because in Italy, if you have, let's say, 50 patients in a unit that are intubated, at the same time you will have like 200 patients on helmet ventilation.
Mm-hmm.
So all these helmets that are made definitely are staying in Italy for these patients.
Mm-hmm.
Yeah. Well, thank you so much. Anything else you want to add and, you know, suggest for others what you have to do to have a success like you guys did?
Keep sharing ideas. The Facebook group is helpful. The website is helpful. All of the, you know, news and even the infographics and the, you know, are helpful to introduce people to how it works in a short, right up in front in your face kind of thing. It's a cooperative effort. It's not a competition. And so we're working with everybody. I've even been in touch with, you know, Nick Messenger from Extol about his helmet and how they're working through it and what problems they had. I shared our experiences with, you know, different neck seal materials and that kind of thing, and haven't heard back from him recently, but he was quite excited to have the input. Yeah.
Well, thank you so much, Scott. And I will wait for the next great news from you.
Thank you, Aurika. It's really great to talk to you. I appreciate everything you're doing for everybody across the world.
Thank you so much.